To community call number 3. We're really happy to be doing these community calls, and it's excellent to have this participation in the community calls, really in the spirit of open source. You get it, you're here, you're helping out, showing up and participating, really appreciate it. And so we've got a really cool agenda that I want to get into just in a bit here. Let me make sure, go to the next one. Just a bit about us at OpenZeppelin. Our mission is to protect the open economy, and to that end, we have partnered with the leaders in the space, the heavy hitters, and a few of them are mentioned here on this slide. And so one of the main focuses of this call is going to be our contracts. This is, we're excited to talk about the 4.6 release of OpenZeppelin contracts for Solidity, and as well to overview the release of OpenZeppelin contracts for Cairo. And as well, we really, not only it's the contracts, but of course our security audits and OpenZeppelin Defender to help manage and automate smart contract operations. And just, I'll hand it over to Fran, who's going to give you an overview of really the purpose behind our community calls. And after that, we'll dive into looking at the new contracts release.
Yeah, so this is the third time we do this. Hopefully we've got a few repeats in here and you already know this. But we really want to be more in touch with folks in the community. We've been getting a lot of participation in the repository, and that's something we're very happy about. A lot of you are making awesome suggestions. We can tell you're always going through the code base and finding all the typos and finding all the issues and pointing them out. So we're very thankful for that. We want to have this space for being more directly in touch. And so we're going to be giving some visibility to the features that are coming up in the next release, which is currently out as a release candidate. It's OpenZeppelin contracts 4.6. And these are the contracts for Solidity. There's a few new features. There's some improvements, and there's also some fixes. One of those new features is related to governance. We've got Ben here. He's going to be sharing his use case, and he also collaborated with us on that. And it was a very interesting process. So we're going to hear a little bit about that. And yeah, hopefully, please use this space. We're gonna have a Q&A section in the end to discuss whatever you want. So on to the next slide, and we're just gonna start with contracts. Part of the reason we are doing these calls is security. So we do our internal code reviews. We aim for high test coverage. And we're also currently engaged with Certora doing audit and formal verification of the contracts. But a big part of the security comes from the community review that you all do. So we've got the release candidates whose goal is to make this space to kind of pause for a second on working on new features and review what's going to be released in a few weeks. So this is what we call the open review period. We invite you all to take a look at what's coming and to review the code. And if you find something or you think you found something, we really encourage you to submit it in the bug bounty we have with Immunify. So more details on the bug bounty coming up later. Quick next slide, show of the changelog. A bunch of things as in the last few releases, and a few of them are actually quite interesting. So let's go down into the details. Adrian.
Yes, let's go ahead and review those features. So the first one on the next slide, this is a cross-chain enabled feature. So this is something we've been working on for a while, listening to the need from the community. It's been requested a lot. It's been studied a lot, and it's slowly being released. This first part is the cross-chain enabled abstraction, which is an abstraction we provide that matches our context contract a bit, in the sense that it's an abstract contract that provide internal view functions as well as modifiers that are useful to know if you're being called through a cross-chain operation, and if so, who is the sender. And that's becoming a really important part of this ecosystem as applications start scaling beyond one chain into the cross-chain world. So this is the abstraction that is just empty. And then we have some implementation of it that specialize the abstraction so that you can easily plug and play different chains. One of the interests of this design is that you can create a contract that is cross-enabled in an abstract way, and then just inherit from either the arbitrum, the optimism, or the AMB part, and you automatically specialize your contract for a specific chain, which might be useful if really you are in the really multi-chain ecosystem. Right now, we have implementation for the AMB bridge, which is kind of a common bridge, particularly used by the Gnosis chain, but could also be used for communication with Ethereum Classic or other networks. And then we have the Arbitrum and Optimism implementation that are really into this L2 space that is really part of the current trend. We also have a Polygon implementation, but due to the limitation of the Polygon bridging mechanism, we are for now only supporting root to child, so mainnet to Polygon or Goerli to Mumbai. The other way around is a bit more tricky. It's a discussion we are having with the community. Keep in mind that for now, the question enable is just about receiving calls, not about sending them. It's something we want to abstract as well. It's a bit more difficult, so that will come at a later stage of development, but it's something we are also really considering. If you have experience in these kind of things as a community member, please reach out. Feel free to reach out at least. If you have ideas of how we could do things, maybe we can do them better. We are really open to external contributions, and we'll be in Amsterdam next week to discuss that with the community members. So don't hesitate to reach out to us. Next slide is about a specific instance of the cross-chain ecosystem contract is the access control, and we are pushing for access control because we think it's a really good design for building access restriction into your contract that in a much more versatile ways than just the ownable mechanism that is more classical. And in access control, basically each wallet has a role or doesn't have a role, and based on that, it can or cannot call some function. And this access control cross-chain is just an extension of access control that uses cross-chain enable, so it's abstract, and you have to specialize it for a specific chain, obviously. And basically what it does is it's creating two versions of the same role. You still have the role in the normal version being used just the normal way, but if a cross-chain call is trying to perform an access controlled operation, then we use the alias version. This is very important because if the same address has different permission schemes on different networks, we don't necessarily want them to be able to access the same function. So if the call comes from an address that already has a role, but through another network with a different security model, then you need to have this role being given in a very specific way through the aliasing mechanism. And the aliasing is a XOR mechanism, so it's easy to go back and forward between the normal and the alias version. So yeah, we'll have a guide on that pretty soon. We understand that documentation for this part is really important. So we wanted to push it as part of 4.7, but more documentation will come, and it's already pretty well documented.
Yeah, I want to highlight a little bit of what you just said. Now that we're all working on this cross-chain ecosystem as smart contract developers, this is one of the things that we need to be aware of. Addresses on different chains can have different authorization schemes, basically, right? For me, a very clear example is you can deploy a Gnosis safe because of the way the factory works at the same address on different networks, but maybe you change the signers in one network and you forget to update the other. And then suddenly, if you were kind of mixing those two namespaces of the two different chains, you have a potential security problem there. So this is where the aliasing that Adrian just described comes in. I also, so yes, the other thing I wanted to mention is part of the use case that we had in mind when we built this cross-chain enabled and access control cross-chain contracts is governance, or just any sort of kind of administration of a cross-chain ecosystem of contracts. You can have your DAO or your multi-sig on Ethereum mainnet and have it manage contracts that are on a layer 2, right? And you can do that across a bridge. And these are some building blocks for doing that. I think projects are still kind of experimenting with the best way to implement those schemes. But these are some building blocks that will be very general purpose, but that's one of the use cases we had in mind when working on them. So the next one that we wanted to mention is a little bit of a security improvement. This is something that was highlighted in the Certora audit, and our governor contract has some operations that are governance operations. They are decorated with this only governance modifier, and the typical ones are like changing parameters. So like if you have a governor, you have a certain quorum, right? And maybe, I don't know, the price of the governance token changes and you want to update the quorum accordingly. So that's something that you would do through governance itself, right? You would make a proposal to say, hey, we need to update the quorum, and then we all vote and do that. When the governance, which is the usual setup, which is has a time lock attached to it, kind of the executing address of the governance protocol isn't the governor contract, which processes proposals, but the time lock. And so the way that this only governance modifier works is it restricts the sender to be the executor, right? And so in the case of a time lock, it is kind of the time lock that can change the quorum, but then that needs to go through governance, right? Ideally. In the case of the time lock controller contract, it can have multiple proposers. And so even though this was clearly in the documentation not a recommended setup, someone could have set up a time lock controller with multiple proposers, and that would have given a potential way to bypass the proposal mechanism. So this is kind of a place where our philosophy for developing the contract shows. We didn't really feel comfortable with the documentation on its own making that recommendation, and we wanted the contract to be more robust against this kind of possible accident that someone would make when setting up their contract. So we just kind of made this modifier a little bit more sophisticated in a way to detect situations that are not the intended setup, the intended use. And it's now, more secure, and that potential issue is mitigated. The next one is a data structure that we had to implement. Well, we wanted to implement in order to do the previous improvement. We realized that this is a very useful data structure, potentially a double-ended queue, right? Where you can push and pop on both ends. And there's a way to implement this that makes efficient use of storage. And we all know how much we like gas improvements. And this is kind of one of the places where we think OpenZeppelin contracts, the library, can provide a lot of value in implementing standard data structures that are just ready to use and making the right decisions about efficiency. So this is a pretty cool, simple data structure. The next one.
Yeah, the next one is receiver hooks. So again, going back to governance, we have this thing that governors are possibly going to have to deal with Ether And with ERC20s, like to manage a treasury like the ENS governance does, the ENS governor does, or other governor do. But no, like it's really clear that ERC 721 and ERC 1155 are also representing a lot of value in this space, just as simple NFT or with the fungible NFT of ERC 1155 that can be used also to represent fungible assets using a single contract for multiple kinds. So those are really stuff that we want the governor to be able to handle correctly. And these standards require the governor to be able to, I mean, any receiving contract to be able to say it's compatible with them. It's not an issue of compatibility on the governor side because they are able to send any arbitrary function, including those that go through the relay mechanism. So we would be able to work with the token. We just need the ability to receive them and receive them in a safe way. So that's why we needed to expose these functions, these hooks.
Cool. So the next one here is one of the big things included in this release, and it's oh, sorry, I jumped one. Adrian, please go.
Yeah, the counselor role is the next one. This is sort of a bug fix. We have this design issue in the time lock mechanism, where as basically there are two roles: there is the proposer and the executor. And we feel that the proposer have way more power because the executor are just here to execute something that went through the time delay. But the proposer are here to propose new updates, and that's really a critical thing. Now, the proposer also has the ability to cancel what they propose or what other proposers have proposed. And this means that if two parties are both proposer, and if they are conflicting, each one can cancel the action from the other, which ends up in a system that is locked and nothing happening, which with both parties agreeing at some point. It's not something that would lead to fund being lost directly, because like parties would have to agree at some point, but the party could become frozen for an indefinite amount of time, and that's bad. So the way we are trying to mitigate this, and it's not a perfect mitigation, but it's really helping, is to separate the proposer and the canceller world, to have those being separate so that someone can possibly be a proposer and not a canceller. Maybe the canceller can be a multisig or something with a different control mechanism. Again, it's all about the creativity of how you're going to configure and assemble this contract. But we wanted to give more options. Keeping in mind that for backwards compatibility, we are keeping the same constructor behavior. So in the constructor, everybody assigned as a proposer will get the canceller role to match the previous behaviors. But it will be possible to have a more granular control of who can propose and who can cancel.
Right. So now for real, yeah. So this is a interesting feature that came out of a number of requests for governance modules. So going over the background on our governance contracts here, we have a set of contracts, the governor contracts, that implement a governance protocol, basically DAOs. These contracts are based on Governor Bravo and Governor Alpha, which were developed by the Compound community and in wide use before we joined this space, the governance space. And so we based our work on those contracts because they were in wide use, there was infrastructure, there was tooling, and they were also widely forked. So there was a lot of interest in this. But so people kept forking these contracts to customize it a little bit in special ways for each protocol. And this forking is kind of heavy, right? You need to take a piece of code and copy it entirely and then try to make surgical changes in a way that is not going to introduce unintended behavior. And then because you did all that, you need to basically audit that new code. And so what we wanted to do here was kind of build a framework where customizations can be more directed, right? So we have a governor framework where we identified a number of modules that are part of this, right? So we've got the module that knows how many votes an account has, right? How much voting power it has. Then there is kind of another module that, given votes, it can count them, right? And eventually reach a result and reach a result in a particular way, right? You can define, do you have abstentions or just for and against votes or some other kind of vote, right? And the parameterized votes functionality that we are adding now is about that part of things. It's about the way votes are counted, right? So the idea here is now a vote, which in the initial versions is basically saying, I want to vote for this proposal, and I want to vote with this support value, right? This support value is a uint8, that is an 8-bit number that is like from 0 to 255. So you've got kind of some space there to express a wide range of options, 255 options, right? But not more than that in this API. And so what happens if you want to build a voting module that requires more than that, that requires more parameters? Maybe you need multiple support values, or maybe you need a whole list of dynamic length of things. We don't know, right? Those kinds of things. One use case that came up is voting with NFTs that are not votes enabled. So we do have now the ERC 721 votes contract that adds vote tracking and delegation to NFT contracts, right? But that's only something you can do for new NFTs, or you can do it for upgradable NFTs. But if you have an existing NFT, how do you make a DAO out of it? Well, one way to do that is, and of course, a secure one, right? Where it's not possible to do double voting. That's essentially the problem that you want to solve here. And so one way to do that is saying, I want to vote, and you give the governor contract, this is my list of NFTs, and I want you to go through that and mark them, each of those, as already used for the vote, right? And so this entire list of NFT IDs doesn't fit in the uint8 support value that was there prior, and it can now, a system like that can now be implemented with these new parameters, right? You can say, here's my vote, and I am parameterizing it by this list of NFTs. And now the governor counting module can go ahead and count that however it wants. So these feature, we realized it would be useful based on a request by Ben here. So I'm going to ask Ben to share a little bit about the thing that he was trying to build. So Ben here is from Scopelift, and I think this is a project within the scope of a Uniswap grant. So yeah.
Yeah, thanks, Francisco, and thanks to everyone from the OpenZeppelin team for having me today. So yeah, my name is Ben DiFrancesco. I'm the founder of a company called Scopelift. We're a small dev shop that's focused on Web3 and smart contract development on the EVM. And as you alluded to, we recently received a grant from the Uniswap DAO through the UGP Uniswap Grants Program to do kind of a bunch of work around making on-chain governance both safer, but also more flexible for the DAO into the future. So some of the work we're doing is very concrete and immediate, and some of it is more exploratory to see what's possible in the future and things that the DAO might want to adopt moving forward. And so this idea kind of fell more into that latter category. So one of the things that the Uniswap DAO saw a need for pretty soon after launching was enabling token holders who had pooled their Uni tokens in some way to still express their preferences in on-chain votes. So a simple example, the kind of first example that was noticed was if you put your Uni into Compound, right? So the compound contract is now the holder of all these Uni tokens. You hold C Uni, but not Uni directly anymore. And so how could C Uni holders express their preference on on-chain votes when this single C Uni contract was the holder of all their pooled tokens? So from that, this idea of fractional voting came in. And in other words, the idea is to just allow a single delegate to split their voting weight, their delegated weight across different preferences. So say, a single delegate that has a bunch of tokens delegated to them could vote 40% of those tokens to for a proposal and 60% to against, or 54, 30 against, 20 abstain, whatever the combination would be. So that was sort of an initial way to sort of enable this use case. And as we began exploring that, we realized that, as you alluded to, the support parameter, which is a 8-bit integer, didn't have enough, basically enough bytes for us to express the fractional voting sufficiently, right? So that's where we began talking with you about a way to extend this and implement it, and we appreciate you guys enabling that. So just a little bit more on what this feature could enable. Of course, an individual delegate could use the functionality themselves, but that's not where we see the greatest value. The biggest thing, as I already said, is allowing pooled tokens to delegate to the contract and then have the contract itself enable them to express their votes individually, and then finally cast a weighted vote to the governor based on the pooled holders' expressed preferences. So in practice, this might look like C-uni holders can vote individually sometime before the proposal closes, and then the C-uni contract, which they would have delegated to, submits all these votes to the governor, expressing it fractionally across all the different C-uni holders' preferences. So pooled tokens are an obvious first use case here, and that's what we're exploring initially, but we also think that there is a lot of other possibilities here, and we'll be looking at some of those as part of the UGP grant moving forward. So for example, a great example, we already heard about the cross-chain work that you guys are doing, and we could see that as well. So imagine something where token holders bridge their tokens, their uni tokens or other governance tokens up to Optimism or Arbitrum. We could now allow them to vote on L2 and then use the cross-chain functionality to move or to communicate all those votes back to a single contract on L1 where they've delegated, and then that L1 contract votes fractionally to express the preferences of all the L2 token holders, right? And this is great because the cost of voting on an L2 is going to be much lower than on L1, so it enables more participation, more direct participation in governance. It also just allows users to move these tokens up to the L2 ecosystem without sacrificing their ability to express their voting preferences. So we're pretty excited about the fractional governance primitive and where we can take that as we work through implementing it. And we think it unlocks a lot of interesting use cases. And so we appreciate the OpenZeppelin team working with us to get this parameterized voting included into your contracts so that we can work on things like this. It's pretty awesome.
Yeah, thank you. It was great to contribute on this. In case it wasn't clear, Ben did all the implementation work here, and we really love having this kind of contribution. We want to have that more. So we're also starting now to use more the good first issue label in the repo. So that's a great way to get started when we identify a problem and there's a clear design for it, and we're happy to have someone move forward and implementing that. Make sure to check out that label. And I think this is also a great example of just the customization power of the governor framework. So we encourage you all to explore that at length. Yeah, so I think we can move on to the next one, and that is re-initializers, another big one. You're on mute, Adrian.
Oh, yeah, sorry. Yeah, the re-initializer is something that we've had in mind that for a while without really seeing a use case. And then the use case was really, really important, and it led us to do it. One of the reasons it took so long also to implement it, it's not just about the contract itself, it's also about the upgrades plugin that we have. So whenever we release contract, we release an upgradable version. This is particularly useful for the upgradable version of the contract. And these upgradable contracts are designed also to be deployed using our in-house plugin, which ensures security. And this, you will see the on-chain, the contract part, but there is also an upgrades plugin part that is hidden that was worked on. And basically the initializer mechanism is here for contracts that are upgradable, whereas you cannot call the constructor because of the upgradability pattern, and you replace the constructor with an initializer. And the initializer is a similar function that must only be called once at construction, but this is not guaranteed by design by the Solidity framework like the constructor is. So we need this modifier that is the initializer modifier, and it's like a non-reentrancy but persistent through time. So you can only call them once. This is really effective for a lot of designs, but it also has its limitation. Usually, let's say you deploy an ERC20, you initialize it, you're happy with it, but then you want to upgrade it. You want to add the ERC20 permit extension that you forgot to put in the first iteration of the contract. That's great because that's what upgrades are for. The thing is that ERC20 permit includes some initialization code that would be part of the constructor if it was an unupgradable contract, but that is in the initializer. But your contract was already initialized in the first place when you first deployed it. So basically, when you do an upgrade, you need to initialize all the modules that you are adding. And we call that re-initialization. And it should be seen as a new phase. Like you had a first initialization in the beginning, and you initialize the phase 2 of the contract. And if you do another upgrade, you might initialize the phase 3. And that's what we are now supporting through a modifier. It's also backwards compatible. So if you created an upgradable ERC20, like in this example, using the previous version of the initializable contract, you can use this new version with your old contract, and it should plug in because it has the same storage layout, and that's recognized by the plugin. So I think this is a great step toward improving the upgradability, the actual upgradability of your contract, and basically using this upgradability to add new features into existing contracts.
Yeah, it's a fun little modifier. So lastly here, we just want to share a couple of details. There's a couple of more content in the slide if you can click through, I think. Yeah, so again, this is all in the release candidate that's out now, and a few other smaller things also, so do check out the changelog. It's amazing. It will be amazing for you to review that and participate in the bug bounty. We have rewards of 25,000. And also, if you find something that affects some other protocol that is also unimmunified, those rewards can stack up. So that's another great incentive to participate. And we also have a very nice set of POAPs for reporting issues. We've already given out, I think, 2 for reporting a couple of low severity issues, and we just want to give out more and more. So just send us your security reports, please. Anyway, here's a link that goes directly to the GitHub branch of the release that you can look at. And now we're gonna have Marto here talk about the new member of the contracts family, right?
Sure, thank you, Fran. So now I'm going to talk to you about contracts for Cairo. Basically, what Cairo is another programming language which is used for zero knowledge rollups, for example, StarkNet. It's being developed by Starkware, the company behind StarkNet. Even though this is just the first release, as you can see, it's the 0.1 release. You can already start using many features. Now in a second, I'm going to show you some of the contracts that come with the package. You should know, though, that even though this library is heavily inspired on the Solidity library, it's not aiming for feature parity. This means we are going to be focusing the development of the library on whatever makes sense for the ecosystem, and whatever makes sense means looking what projects are trying to build, what problems are having them on layer 2, for example, communication bridges. So we will see whatever the ecosystem needs. So now if we go to the next slide. Oh, sorry. One thing to notice on this slide is that you install the library by using pip. This is because the Cairo ecosystem is heavily linked towards Python. So now we can go to the next slide. So even though this is just the first version of the library, you will see there's many contracts already in it. Most notably, it's the account contract. This is because on StarkNet, there are no EOAs, there's no externally owned accounts, so every account has to be a contract. This is kind of cool, actually. You can check out the standard account contract on that repo. This has been developed in jointly with the Argent team. They've been working a lot with us to standardize how accounts should look in StarkNet. We also have some tokens, ERC20, SEN21. We have some flavors of them. I'm going to talk about that in a minute. We also have proxies, we have upgrades. There's a very cool UUPS similar proxy pattern, which is looking really cool in the Cairo language. We have ownable, we have postable, we have a small version of safe math. We also have introspection features like ERC165. And we have many incoming features like access control, token 1155, and many other contracts. If you have any particular needs with that, please open an issue in our repo. First, check if there's not an existing issue, because we had some race conditions over there. Now, if we go to the next slide, I'd like to mention how would you use these contracts. So basically, there are two ways of using our contracts. We have what we call presets, which are similar to the existing presets of the Solidity library, which are basically ready to use contracts. This is, as you can see in this slide, basically you just import that contract and you deploy it right away as it is. This helps a lot to streamline development. But also, if you want to have your own custom contracts, you will need to modify them a bit. So instead of using a preset, you would use a library. So if we go to the next slide, you will see a short version of how using libraries look like. Basically, because of how Cairo works, it doesn't have any inheritance nor function of overloading. So if you wanted to, for example, modify how the transfer function works, in this example, we have a transfer function that has a postable when not post function, which is basically similar to a modifier. It's like a word checking that the contract is not post to perform this action. In order for you to modify the existing functionality of the libraries, you need to import the function library, in this case, the ERC20 transfer function you will see at the end of that transfer function, and you need to re-export that on the Cairo library. This might sound like a lot, but it's not that hard. Anyway, you will see we just released a blog post with a tutorial for you to follow, do your own token. Finally, one more thing I'd like to mention, which is the last slide, is Nile. Nile is basically, it's a dev environment tool. It's like a hard hat, like a Foundry. It's basically a tool to help you streamline development. It helps you compile, deploy, debug, send transactions. You can write your own custom scripts, and we just released support for custom plugins. So you can extend the functionality of this tool however you like. Again, this is both these projects, well, most of these of the contracts projects, but this Nile particularly, it's super open source in the sense that it's mainly driven by the community, and I think that's super cool. So please feel free to send a PR, participate. It's a joint work.
People seem to like Python or something, right?
I don't know why.
Okay, so yeah, we are hiring a bunch of positions. These are just some of them. Feel free to go on that link and learn more about that. And this is what we had to present. We can move on to Q&A now. We have already one question. Oh yes, one more reminder that our team is going to be in Amsterdam in several events. So if any of you all are going to be there, feel free to reach out, and we would love to chat. Yes, so Q&A questions. Michael here asks, he saw a broken link to cross-chain docs. Yeah, so because it's not released, the docs aren't live yet, but since we are gonna be participating in Layer 2 Amsterdam in particular, and we're gonna be talking about this to people, I think we are gonna put up a a pre-release docs page. Anyway, that's to say, yeah, this link is broken. I'm gonna make sure to, we're gonna make this public soon, in the next couple of days, and fix that link. Yes, including a lovely guide on how to use the cross-chain enabled contracts. If anyone else has questions, please feel free to go ahead and ask. Meanwhile, if not, I would love to get a couple more thoughts from Ben on L2 governance, what's happening in that space to your knowledge.
Yeah, I mean, I think the short answer is that as y'all know and have alluded to, like, I think every project is sort of struggling with this right now, right? Which is that most projects have a governance token deployed on L1, and you know, occasionally some projects do have actually their governance token on L2, but increasingly users want to do things cross-chain, and the DAO needs to have provenance, or at least it would be ideal for DAOs to have provenance over things that are happening on various L2s. And so I think it's a thing that a lot of projects are struggling right now with. And I think the work that y'all are doing is a really great step in the right direction toward sort of standardizing the approach here, abstracting away the details that normal developers, so that normal developers can sort of implement this cross-chain communication in a secure way, because I think it's increasingly something that is going to be very, very common. So yeah, we're just seeing a lot of our clients, a lot of people that we talk to about client work. This is the kind of stuff that they're dealing with, like how to make their projects work in a coherent way across multiple networks.
Yeah, we also heard from Pool Together. They're actively working on this, and we're kind of collaborating with them on a potential solution. You can find it if you Google Pool Together multi-chain governance. You're going to find a repo there where we're working on a proposal, but still kind of figuring out the space.
Yep.
We do have a couple questions in the chat. Marto, I think you're the right person to answer these, as they are about Cairo.
Sure. So the first one is, how would an AMM, I missed it. How would an AMM interaction for Cairo tokens would look like? I'm not sure I understand the question, so I would expect the same way as in Solidity. Smart contracts, even though they're written very differently, and that they run in a different environment, instead of being the EVM, it's the Cairo VM, so it's its own virtual machine. The overall idea of contracts, calling contracts, is pretty much the same. So you could have tokens, most probably in an ERC20 or similar implementation, and then you'll have a contract that knows how to handle those. Let me know if I missed the actual question. Another question would be, for a dev looking to build with Cairo, where should they start? Also, are these tools, e.g. Nile, ready for production level dApps yet? So it depends on what you call production. So there's many releases of StartNet in different testnets, even on mainnet, but it's still on alpha. So depending on what you're calling production, even though these systems are live, there's a warning that until they leave their alpha status, they might wipe the whole state of the network. So depending on what you call production. That being said, I'd say it's one of the more, if not the most mature tool to work with Cairo. And where to learn, I'd say the official documentation should be the best. Also, there's a very good, awesome StartNet repo by Georgios Konstantinopoulos from Paradigm. That's a very good index. And then one small warning is, beware, even though there's very, very good community content, Cairo as a platform evolves too fast. So it's very common to find outdated content. So beware of the non-official documentation.
If I can add here, I started looking into Cairo recently, and one of the resources I found very useful was a Git repo called StarkNet-Cairo-101. I'm sure you can find it very easily. and it's a set of exercises to learn how to interact with contracts and to read contracts. And this is, I think, a good stepping stone because it doesn't require you to write any code, compile any code, set up any environment. It's all like testing you do from the browser. You need the Argent extension for that, and it's really nice to have a first glance at how this ecosystem works, how the contracts are designed before jumping into writing your own and compiling them, which can be cumbersome.
Going back to the AMM question, one thing that maybe is interesting to note is, what about the token standard? Are we using ERC20 in StarkNet, and like is the API kind of the same, and should people expect more or less that Ethereum experience would translate?
Good question. So it's not super clear. So as I've mentioned before, the machine that Cairo runs on, it's very different from the one that Solidity is running on, which is respectively the Cairo VM and the EVM. And even though right now existing tokens on StarkNet try to comply as much as they can with the ERC20 standard and other EIP standards, there are some aspects that they cannot comply with. For example, how selectors are computed. That's very different on each machine. So I'd say users should expect an approximation to standards. They should know there are some rough edges. And at the same time, this is an open topic on the community, and many different aspects of designs from contracts to protocol level changes are being thought around compatibility with the wider Ethereum ecosystem. So I'd say it's okay for you to expect kind of similar contracts, but you should know there are some differences.
Thank you. Yeah. Stephen, can we show the POAP claim link? It's you can find it in our Slack channel, and we can show it here for a bit for people here. If not, let me know. Meanwhile, there is another question here in the chat. Can you create a contract which can receive messages from multiple source chains? How would it determine which cross-chain sender implementation to use? Yeah, this is a great question, and the answer is the cross-chain enabled abstraction is kind of too simple for that, right? It is tied to one chain for now, at least. Actually, that's not exactly true. The cross-chain enabled abstraction is tied to one bridge, right? You could, in theory, have a bridge that has multiple source chains. So that could happen. However, the way that we implemented this and included this in the release, the actual code for understanding cross-chain messages is in standalone libraries. And the reason we did that is so that someone that wants to experiment with multiple source chains or multiple bridges can do that using those libraries. So yeah, I don't think we can show this on the screen now, but if you go on the repo, you're going to see there is this new directory inside of contracts called cross-chain. Inside of the cross-chain directory, we have a directory per chain and per bridge, right? And so then if you go to, for example, Arbitrum, you are going to find this libarbitrum library, which contains the real logic. So if you want to do this, a contract which receives multiple messages, that's the route you should go for now. I think that is kind of too much of an unexplored space for us to provide something out of the box. I think like the implications for that are not clear to me. Even the security implications, right? It's like, I mean, we definitely encourage you to experiment, and that's why we built it in that way, but it's going to be a little bit more manual for now. I don't know if you wanted to add something to that, Adrian.
No, I think you nailed it pretty clearly. Yeah, it's not something we're encouraging, or we don't have any all-in-one solution for that, but it's something we have in mind, and we have the code that should allow that, but you just will have to go to a lower level. You will not be able to use the abstraction, or maybe you can create a meta abstraction on top of that, but It's definitely not something we want to ship for now.
Yeah, Alejandro, if you have a clear use case in mind, we would love to hear that. So feel free to jump on the repo and share that. The use cases helped design the right feature. Let's just solve the slide thing. Stephen, if you refresh now, that should be. If you refresh the slides now, they should be there. The slideshow button.
I'm ready to claim.
Final slide. Nice. Okay, there we are. All right, people. This is now a real meeting. Oh yes, maybe this is a cool moment to share. If any of y'all have been contributors to OpenZeppelin contracts over the last several years, there is now a Git POAP that launched this week. This is a kind of an offshoot of a POAP that grants these NFTs for contributing to open source projects. And OpenZeppelin contracts is one of the open source projects that is there at launch. And if you have a contribution, even as simple as fixing a typo, you're gonna get a POAP from that. So make sure to go to gitpoap.io and see if you have any to claim. There's also Hardhat in there and Truffle and Ethereum.org as other projects that, if you contributed, are gonna get you one of these. We think that's pretty cool. Very really like this project actually. Okay, anyway, if people are having issues, we're gonna send a claim link, don't worry. All right, I think we can finish here. It's been great to have you all and hope to see you in the next community call.
Thanks, everyone. Take care.
Thank you.